Hey guys, this is our Module 3 lab video. We're going to cover throttle position sensors, a little bit of accelerator pedal position sensors, and engine coolant temperature sensors. So getting right into it, you can see I have drawn out here a wiring diagram for the throttle position sensor on my O2 Silverado. You can see we have our 5-volt reference, our sensor signal, and our ground. And you can see we have that variable resistor, and I drew out the multimeter that we're going to be reading voltage off of for a sweep test. We're going to sweep test our throttle position sensor, and this is an O2 Silverado, so it's a simple 3-wire sensor where the throttle is actually still driven by cable here. We have our multimeter reading voltage, and we're tapped into the sensor signal wire. So as you can see with the throttle closed, we are actually at 0.5 volts. And to sweep test it, and you can use a multimeter reading volts, or you can have the sensor out and you would read ohms from your signal wire and either VREF or ground. But we have it plugged in, so we're reading volts. And a better way to do this actually would be using a picoscope, because you can really look at, on the graph, the voltage come up and down as you open and close the throttle, and it's easier to see some imperfections in that voltage line. But this is kind of the gist of it. You want to slowly open your throttle and watch your voltage increase. And we're just looking for, weird erratic spots. And as you open it all the way, we work all the way up to our 4.5. And come back down. Throttle's closed again, we're at 0.5. So there you go. Right, so now we thought we'd take a look at a typical 6-wire drive-by-wire throttle position sensor. This is a wiring diagram for a 2011 Chevy Equinox, and as you can see here, we have our throttle body, and this is going to be our one of our signal wires, and this is going to be our other signal wire. This one is a pull down, while this one is a pull up resistor. So we should see that we're going to start at closed throttle with a higher voltage here. This one's going to start with a lower voltage here, and as we open the throttle, this higher voltage is going to come down to around 0.5 volts. This one's going to work its way up to around 4.5 volts. So we're going to demonstrate that test on the car now. We're actually on the car here, and you can see this is our sensor connector here, and right now I'm tapped into the first signal wire, and it's that green wire down there. And this is actually on the wiring schematic I just demonstrated, has a pull down resistor. So with the throttle closed, you can see we're actually, it's about 20% open, but if I close it there with my finger all the way, you can see we're close to our 4.5 volts. So this one's gonna start high, and if I get something here so I don't pinch my fingers if anything happens, to open the throttle, that one's gonna work down to our, close to 0.5 volts. And now if I take my connector here and tap into that second signal wire, we should see this one's actually going to start low with the throttle closed. And so we're at about 0.6 volts, and as I open it, that's going to work up to our 4.5 or 4 volts there. So they do this as a safety with these sensors, so if you were looking at it on a graph, they would, cross each other. And that's just so the PCM knows, that if one signal is at this spot, then the other has to be at that spot. It's just a redundant sensor like that. So that's how you can simply test one of those. Now I just wanted to touch on APP a little bit. As you can see on that right hand side in the middle, we have our sensor and it's very similar to the throttle position sensor. It has 2 signal wires, and I did stretch out my spinal cord and get under the dash and back probe those wires, and they both started low and worked high and just had a little bit of a different voltage, but it's the same exact concept as your throttle position. Now we're going to get into engine coolant temperature sensors. So this is a diagram for a 2000 Buick LeSabre. And down on the bottom of the diagram, 2 sensors to the right you can see our engine coolant temperature sensor. And we can't see inside the PCM, but it does show us that our yellow wire is our input and our black wire is ground. So this did turn out to be a dual range ECT on this car, but I'm going to talk a little bit on that later. So here we have the PIDs pulled up, and you can see coolant temperature. Currently we're at 63 degrees Fahrenheit, and now I'm going to have Anton go and unplug the sensor, and we're going to see that it should drop to about -40 in that range with the sensor unplugged. So yeah, now you can see, if I can get the glare off this thing, we've got about -38. So now we're gonna start the car up and monitor the coolant temperature and the voltage on that input wire as the car warms up. Okay, so now we're actually going to look at the voltage on that input wire and compare it to the PID for the temperature reading as the car warms up. And you can see here, starting out, we're at about 70 degrees Fahrenheit, and we had 2.3 volts around. I cut forward now, we're at 1.4 and got, around 100 degrees Fahrenheit. Here you can see we're at 1, but watch, it's going to jump back up to 3.7-ish, and that is because this car actually has a dual range ECT. Now that's internal to the PCM. It switches to another lower resistance to bring that temperature, or to bring that voltage back up, so the reading can be more accurate when the car is hotter. Here you can see I'm feeling the upper radiator hose to make sure the thermostat's open. We're at about 190 degrees, and we've settled kind of into our operating temp at 2.1, 2.2 volts. But essentially, the voltage is going down as the temp goes up because it's a negative temperature coefficient thermistor. So as temp goes up, voltage and resistance goes down, and that's why those readings are that way.